Okay, well, thank you. Thank you, Mike, for the that nice introduction. And thanks for the invitation to come and speak. Sorry, I haven't been at the first 2 days. It's been a fascinating conference. I tried to get for some of yesterday, but wasn't able to. I was asked to come and talk about public views of geoscience decarbonisation, and I will move on to that. But I guess my wider message is, years ago when I started work in the risk field, I wasn't in the public perception field, I was in the major accident field. We were trying to work out how things, aircraft crashed and bridges fell down and tower blocks landed on fire or whatever. And one of the major overwhelming insights that came out of that area was that actually it was very important to learn from other areas, that your next accident in Shell probably happened in British Airways 3 years ago in terms of its organisational and human consequences. So my main lesson is, let's think about learning across both things within the geoscience domain and things that are outside. And if that's difficult, because you often think about your own technological options and are always kind of worrying about heat, hydrogen, or worrying about CCS, try to think beyond your own particular interest and try and work out what lessons there are there. And that being said, of course, there are a whole bunch of technologies here that are being discussed in this meeting, and we can go across them, lots of differences between them, but I would argue there are some similarities as well, particularly if you think about the people culture and the process issues. And I'm afraid this is sometimes it's an unwelcome message. I know that if you sit in a very renewable type of technology, to be told there are some less like technologies which you might learn from. So, and the two which are obviously particularly controversial are radioactive waste disposal and currently unconventional gas and oil extraction. And so there's always a resistance to say, well, energy storage isn't like radioactive waste. Well, it isn't at one level, it's not. It doesn't have that radioactivity thing, but it may have some process and other things that you can learn. And that's my message basically today. Think widely about what this all means. The other thing on the bottom of the slide is it's very important to not mix up, or well, they get mixed up in public views and in how we deal with these things. With all of this stuff, there's a national set of discourses and imperatives around climate change, energy security, renewing the energy system in this case, and then all these local siting issues. And actually, it could be the siting of a new ASDO that's not needed, Tesco's in Falmouth or something. Once you get down to the local siting issues, there really is huge research base on the sorts of things one might be thinking about. So that's worth bearing in mind. I'll come back to that as we go along. And I'm going to try sort of to show aspects of both sides of that, the national and the local. So something I raised, actually it was about 5 years ago here, so we want a social science of the underground, which sounded too much like the tube. So in a recent paper, we've said, is there an argument for a social science of the subsurface? I think that's been answered yes, actually. If you look out there, there is a literature that's emerging. It's quite a small literature, big one around rad waste, that's been going a long time, quite a few studies of CCS, not much on energy storage currently. But both philosophers, historians, psychologists like myself, and geographers and others are starting to think through these problems from a more social science question. So there's a literature there. That's the first thing to say. If you want to go and think about this stuff, you can find it. You probably need to ask the specialist to point you in the right direction. And I think we need more of that as well, more, and the research councils are trying to do more cross-disciplinary research, and that's absolutely right. A bunch of cross-cutting issues, and I'll go through these just briefly. One is obviously, what do we know about risk and benefit perceptions generically? Then there are issues of trust in technology, others, institutions, always cut across citing issues. There's no doubt about that. And trust is a very, very difficult subject, one we can have a whole symposium on ourselves, and I can talk about that in the break if people want to chat about the research that's been done on risk and trust. But basically, if you don't trust the organisation managing the technology, or the governance arrangements, or the process that's been put in place, then you're likely to see it's more risky and you're likely to be less prepared to accept benefits. It's as simple as that. And lots of studies have shown that relationship across a whole host of technologies and issues. A process and distributional equity, I'll get onto that, very, very important. I don't know, Ben Severcourt talked yesterday, and he may have talked something about equity and justice in his talk, because I know in Sprue they're very interested in that question. I'll talk a little bit about values around energy system change, some of our recent work from the UK Energy Research Centre, and narratives of the underground, very important. I'll come back to that right at the end. And the point that however much you'd like to wish them away, perceptions do have real consequences. So there's been an interesting debate. When the tube bombings occurred in London, the following week and so on, people avoided using the tube. And then there was an argument, actually a very poor argument that was put, that because people were walking and cycling into London in an unfamiliar way, which they were doing in greater volumes, there were more cycling accidents, and therefore more people were actually injured than they would have been had they stayed on the tube, which by that time was perfectly safe because there were lots of checks in place because we'd had these horrendous events. Now, actually, that kind of neglected the fact that if you cycle into work, you get a huge health benefit from it. So actually, people probably were taking a rational choice in some respects. But they have real consequences. Lots of examples there where perceptions lead to people changing their behaviour, doing things, sometimes doing positive things, actually. It's not always negative. And I'll come back to that as well, that there's a positive side to all of this research as well. Just to say, and you'll know this, that if you, as I've said, you can look back at other technological controversies or things that have gone well, actually. Nanotechnology is one of the interesting domains that I've studied over many years, and we thought it would go like GM food and or agriculture and be a real big controversy, but it's actually been quite difficult to get people exercised about nanotechnology. They just see it as a nice bit of science that will produce good advances in most domains, good advances for society and for people in general. So that was an interesting technical domain where we thought there'd be issues, and actually it didn't turn out to be the case. But you can look at biotech, the BSE crisis from many years ago. Nuclear power has been the one that's been studied most and that psychologists and others first started to look at. And there are lessons, and overhead power lines have also been studied, lessons from all of these, which feed into some of these more controversial issues around geoscience. As I say, the people side is often common. Many years ago, colleagues in the States published this really well-known study. It still has some purchase. They asked people about a whole bunch of technologies, which are kind of shown on the screen here. What they discovered was that people kind of, in perception terms, looked at them in terms of two factors. One was they called dread risk, which goes from left to right, higher on the right-hand side of the diagram. And basically, actually, it's now been understood as sort of an affective response. I just don't like that. You know, it upsets. You have an emotional response to it at a very kind of gut level. And then unknown risk, which is an important one, more unknown at the top of the diagram. So you can argue that, so they argued that things like home swimming pools, which actually killed quite a lot of people, were not particularly dread and were not particularly unknown to people. Therefore, risk perceptions were relatively low. People might take precautions, that's a different matter, but because they knew people would die from swimming if you didn't do the right thing. On the other hand, nuclear power, which is rad waste, which they were interested in, got this very high dread score and very high unknown risk. The scientists don't know what's going on. What I'll point out, which is, and the unknown is interesting, isn't it? Because the deep subsurface is pretty unknown to us, and the geologists amongst you will say, well, we don't know everything about what's going on. So there's immediately an issue about unknown risk and how perceptions are formed around what is known about the deep subsurface. The other thing I'll note is a lot of the things that were sort of unknown are kind of chemical contamination issues, and those are known to be particularly tricky as well. And I'll come back to that because that relates to a number of the questions of intervening in the subsurface. Would we contaminate the subsurface? In terms of perceptions, it's quite easy to do research on this. This was from a study in Nature Energy on shale development under the M4 shale program. And we asked people just what first images come to mind around in the UK and in California at the same time, exactly the same protocol. What were the benefits of shale development? And actually, there's a positive side. People saw that there was an energy in the US. It was more framed as independence, security, and energy type set of benefits. But as some of you may know from looking at the literature and all the other data from that study and other studies, many other studies that have been done, show that the thing that people really get upset about with shale is the potential contamination of the subsurface, and in particular potential contamination of water. And in California, not surprising, earthquakes came up as well as part of the mental model. Wonderful quote from somebody: why would you do it here? We got this earthquake problem in California. Why would you poke a sleeping bear? Which is a wonderful quote to kind of sum up what people were saying there. But the water contamination thing is very fundamental because people see water as the fundamental of life. And if you're really messing about with that, or there's a risk of messing about with that, then things are less acceptable than otherwise. And I think that's the key thing around shale development that really worries local communities. Social context is also important. So controversies can arise quite quickly and overnight, or are as a part of a historical or social process. So sometimes you have to look at what has gone before to understand what's going on the ground. And there's a model which I've worked with called social amplification of risk, which is not just about things getting worse. Sometimes they become attenuated when they shouldn't be. Things interact together, and a whole bunch of different processes interact. And this was from a Department of Health document that kind of summarized what gets the media exercised about a risk issue. And there are a bunch of factors there, questions of blame, secret, human interest, high-profile issues and persons. An issue that's got several of these sitting there together, or one in really great, that's really flashing out at you, is likely to get some media attention. So the media then becomes an amplifier of the risk issue. So the ClimateGate question almost 10 years ago now at UEA with the theft of the emails from their server became a huge media thing. Primarily because the claim was that the scientists had covered up and they really shouldn't have been doing that. Now, that was not true, and I know some of the people involved, they said it wasn't a fraud going on there. But that was how the media interpreted the release of those emails. Another one you may know less about, the ash tree dieback affair, which occurred 5 or 6 years ago now. And definitely, this went from ash tree cholera. It's not that it suddenly appeared, it was known it was sort of coming in the direction of the country, but suddenly there was confirmed cholera cases amongst ash trees in the country. And then within a month, it had gone from nowhere on their risk register to the minister was asking what on earth was DEFRA and everybody doing about this. So and there were a whole bunch of things that went into that, particularly signal value. What do trees symbolize to the British population? Very, very important, actually. If you look in the research on that, and that there was a threat to a wider kind of devastation of the landscape as a result of this disease which had come into the country. So things can suddenly catch you out as well, and there's no way you can control it. Actually, you just have to run with it and understand why it has happened. Now, I'll make this point. I was with colleagues in the Netherlands last week, and they made exactly the same point from independently thinking about this problem. The social AMP model says it's got two stages. One is what processes lead to something becoming a big issue in society, and then secondly, so that's those kinds of things. Secondly, so fracking is a good example, but then secondary consequences. So you can have secondary consequences in related but not the same domain. So something I suspected for a while, and my Dutch colleagues said, it looks like there's a spillover going on here, that people are getting very, very negative views on fracking, and then suddenly when they hear about deep geothermal or they hear about energy storage, they ask the question, is this the same as fracking? And there's a real contamination issue that we might want to talk about in questions that's potentially there. And it's actually a live research issue, that is there a spillover from all the controversy about unconventionals onto some of these other technologies, which certainly would be more, would be seen as more beneficial to the energy transition in a sustainable way. Important question, I think. The other thing is you might say, and we might discuss, well, let's tell more people more about the science and how good all this is. We've known for many years that just giving people facts about the technology and how safe it is doesn't necessarily change behaviour or attitudes. And the House of Lords discussed this as a result of the BSE inquiry a number of years ago. Basically, if you go back many years, this was trodden with radioactive waste. This is from a 1991 paper. The US Blue Ribbon Commission on Rad Waste, which is much more recent, has a very similar set of procedures. We were asked a few years ago by the Bulletin to summarize this literature on rad waste, or on nuclear and rad waste, for renewable systems. We were thinking about wind at the time. But basically, you can go back and look at, and all of these proposals are sensible things to think about if you're thinking about siting technology that local communities might be concerned about. And basically what it means is process and distributional equity actually matter. How you do it, mostly you've got to go talk to people very early and find out what they're concerned about. And then the balance of benefits is very, very important. It's no good if the local community don't benefit. Moving on, at the national level, discourses of energy system transition, values matter. We did a very large project for UK. Oh, I'll show this. This is actually quite important. You might wonder, this is not my nephew's scrawling. It's actually some participants in an energy storage project for EPSERT we did about 2 years ago. And as the first thing when they came into the workshops, we asked them to draw where their energy came from. And although a couple of people in Aberdeen, I think, drew oil wells offshore, none of these images were underground. So people didn't have a model of energy coming or being associated with the underground. So there's a blank canvas there anyway that needs to be filled in some sense. And I think that other things are missing, but that was one of the key things that was missing. Any idea about storage, actually, and any idea really about the underground. So that's interesting in and of itself. The UKERT project, what we did, this was a major piece of work over about 2.5 years. The report, I've got one copy, which is worth reading again if anybody wants to take one away with them. We know a lot about the elements, perceptions of the elements of the energy system, but much less about what people would say when you gave them the trade-offs and how the system would change as a whole. So why would you need CCS? Because you'd need to deal with potentially residual gas emissions, let's say, or you might need it for negative emissions. Why do you need to insulate your home? Well, because that kind of generates more efficiency and therefore you don't need to burn less gas and coal, etc. So we put the whole system change in terms of a number of scenarios to people over a whole day. What we did, quite extensive workshops in 6 locations. Each one took a day to go through. We had about 12 to 15 people in each workshop. And there were a number of challenges of trying to engage people around that, primarily about getting across what it's all about and getting people to think through the problem and in a balanced way, as far as that's possible, and to get people to think about the system as a whole. But I won't go into that, but that's been written up as a methodological piece. We were lucky to have DEC's 2050 calculator, since taken offline. They're redoing it, apparently. But we used this with people, so we took people for about 4 hours and sat them down in front of the screen with the calculator here. Those of you who don't know it, it's got 14 levers. You've got to try and reach the carbon target by having more biofuels or less oil and gas or more. I think CCS is clean coal and gas power, which is the lever goes up. And we had a long debate about each of the levers and what they meant and how they interacted with other sides. There's also a demand side as well to do with how we actually use energy. Very interesting, and hopefully DEC or BEIS will bring it back online at some point. Thank you. But the basic finding was that there are a whole group of values that people wanted for the energy system and energy system change. In particular, and I won't talk about them in detail, but they wanted reducing the use of finite resources, which is why people don't like oil and gas. Not so much about climate, it's about they think they're finite and running out, and we shouldn't exploit the planet, and reduced overall use of energy use. So those are the 2 meta values at the top, and then a whole bunch of other things were required for an acceptable energy transition. Actually, this is a very positive message because it says people do want an improved, better, cleaner, more sustainable energy system. I don't think there's any doubt about that. That was a clear conclusion from the project. But it meant some things kind of were ambivalent, and one was CCS and one was biofuels. So people are not 100% with them. And why? Because they transgress some of those values. So we discussed slightly ironically CCS. Nobody said that it was a non-transition, but that was sort of what people were saying. About biofuels, it's another oil. It's a step backwards. It just seems like somebody panicked and said, let's burn more stuff. But wonderful quotes from some of the people who took part in that. And a similar sort of sentiment with CCS, that it's perpetuating the oil and gas industry, and you've told us we've got to change away. So why are we doing this stuff? It's a good question as well. Think about that. The other thing about CCS was, should we take waste from elsewhere? So here's somebody in Glasgow worrying about not necessarily taking English waste, maybe waste from Europe or wherever. But they weren't very happy about being the dustbin for this kind of stuff. So there's a local component, and then this all looks a bit complicated. Somebody's going to make a mess up somewhere along the line. So this looks like a complicated scheme to deal with this problem. Why can't we just put more insulation in our homes and not use less energy? So if people can get it wrong, they will. And back to my major accidents work, absolutely correct. No. So if you think about these values again and think about what I've said about CCS, it contravenes some of these, not all of them, but some of these. So it's not, people didn't see it as particularly an improvement. It had some safety issues. It wasn't reducing the overall use of energy. It wasn't actually helping us with the reduction of use of finite sources. There were some environmental protection questions. And finally, the social justice issue about taking other people's waste. People are uncomfortable sometimes about that. So it didn't tick all of these boxes. I think that's the way to read that table. And then finally, and I will finish, just some thinking we've been doing. So I tried to show, therefore, just before I go on, the local component to all of this, and there's a lot of literature on that, about equity and process. Again, we could have a whole conference on that question. And then the national thing that cuts across, that you have to think about how people do have views on these more policy-orientated questions, and will have sensible views on them if you have a sensible conversation with people about it. Finally, we just had a paper accepted for environmental values based upon the fracking, the unconventional oil and gas project in the UK and the US. And as part of this, we first looked at the risks and benefits, and we looked at the equity stuff. But then we were thinking, well, people were actually saying some interesting things about the subsurface here that were slightly deeper, and there were a set of narratives that were resonating with why people were uncomfortable about this technology. And I should say, these are very generic issues, so they are likely to be lurking or arise when people think about any other particularly deep geological intervention, as many of the technologies we're talking about will be. And there were three that we talk about in the paper broadly. One is the problem of the Earth as a foundation. The second, natural limits. Natural limits, actually, if you look at many of the other technologies, the thing that people get very uncomfortable about is what they call messing with nature. So biotechnology has been always, certain aspects of biotechnology have been seen as messing with nature. So you're crossing the limits that nature has set for us. The other one, actually, climate geoengineering through solar radiation management is seen as very much messing with natural systems. And there's a question of whether you're doing that also intervening in the subsurface. And then something that's pretty obvious, actually, there's an uncertainty around the system's fragile, probably, there's probably instability, and we don't know much about it, and how can we deal with that? And that's always a problem with risk issues, that actually, and I know geologists, those of you who are geologists will say, well, we don't know fully what's going on under X unless we've done a borehole or several boreholes. So we're always trying to kind of infer with some level of uncertainty. So it's very difficult to actually meet that question. So I'll show you just 3 quotes, and then I will wrap up. This is the Earth as the foundation, this sort of narrative that, well, we depend on, it's a bit like the water idea, and air, water, air, and earth. We depend on this for life. We sit on it, our buildings sit on it. I suspect if you went to Friesland and talked about the issues that have been going on there around conventional gas production, this is precisely what people would say, that you're actually messing around with the foundation of life, basically. So there's an issue about intervening there that makes people uncomfortable, I think, in relation to interventions in the subsurface. I don't have simple answers. It's not a question of kind of trying to counter that discourse. That discourse is there, and therefore having a sensible conversation with people about it is very important. The second, the natural limits. Again, intervening with nature in appropriate ways. We had lots of quotes, but that's just an interaction between some people. Again, in the, I'm not quite sure, that may be from Cardiff, actually. So who's owned by it? It belongs, well, and it is different in different countries, of course, isn't it? But no, it belongs to the earth. Mother Nature doesn't have a vote. She doesn't have a vote, but she does have a voice, but we choose not to hear it. So again, this idea that subsurface is not something that's owned by us or by governments or by individuals, that nature is owned by herself. And again, intervening there has to be done in a careful or a well thought through way. I think that would be fair to say. And then finally, the question really of uncertainty, which comes back to trust again. If you look at that quote, what people are really saying is, well, you've told me this is all fine and it's safe. I don't really trust you. I don't really trust the government. I don't really trust these oil drilling companies or whoever's doing this work to actually do what they said they've got to do. And that's a really, really difficult question. And it's one that is not straightforward to overcome. It's one, again, where you think about the social amplification model, if you're thinking about the debate about fracking has got to a debate about trust, basically. And that's where the spillover is likely to occur, that we don't trust this industry. Therefore, why should we trust them to do drilling for some other activity? So that's all I wanted to say. I'll conclude with, just to wrap up, the first thing I've tried to say, it's very important to think about learning across domains. And don't feel in any way inhibited to think, where has this happened before? Or where's the knowledge that will help us to think about some of the parallel questions that might have actually been solved and dealt with in other domains, or at least thought through in more detail than they have here. You also have to consider that discourses and understandings of the subsurface and perceptions of subsurface interventions will have this national level aspect to them and local elements. And sometimes they get mixed up, and in dealing with one, I mean, it's a huge tension, isn't it? If you go to a local community and say, we need this compressed air storage facility for national reasons, and the local community said, but we're getting all the risks, immediately the two sets of things are set off against each other. And there's no simple resolution of that. Who decides is a big issue in all of this. Which is why often the debates come down to the legal process for who's got the say or the veto or the say for it to go ahead. Perceptions matter and have consequences. I hope I've kind of demonstrated that. And knowledge alone is not the issue. Knowledge is important. You need to give people accurate and good and trustworthy knowledge about what's going to be done or the proposals that are there, but it's not necessarily the only thing that sways people in terms of their perceptions. Social context is important. Sometimes that's just very, very difficult in any sense. You don't have control over social context. Other actors do, the media. Interest groups on both sides of the fence do things that they shouldn't do from time to time, make claims that they should or shouldn't do, and that can generate both risk controversy, and it can generate lack of attention to risk that should really be dealt with. So that's just be aware of that, and when it happens, it's worth reflecting on it. People's values matter. And this final point that I think very few people have really worked on, and that we're quite interested in, is there a narrative of the deep underground that from a social science perspective, is rather interesting to draw out, write about, try to understand how people are understanding the sorts of technologies that are being proposed here. And that's it. Thank you very much.
Thank you very much. Great. Any questions for Nick? And you wait for the microphone and just say who you are and then speak. There's one here.
Bob Holsworth. Bob Holsworth, I'll be talking for a minute. So,
Okay.
Question. Transparency.
Yep.
In these issues. Is it a good thing or is it a bad thing?
Always a good, well, it's always a good, no, let me put it the other way around. Not being transparent is always a bad thing, right? Because eventually you might get caught, somebody might get caught out if you're not saying what really. So I think generally it's a good thing. It can generate issues, so it can become part of the amplification cycle. But if it's done in a genuinely transparent way, then people, eventually it shakes down as, well, that has been done in good faith. And I think that the trust issue, if you come back to the trust issue, one of the conclusion of the House of Lords report was openness and transparency is absolutely key. What went wrong with BSE was the government said there wasn't a risk when actually lurking under it, the scientific committees were starting to discuss it. So there was not quite as much transparency as there could have been. That was a lesson there. I think Radwaste went through that one as well, and they've just realised that openness and transparency in everything they do, as far as they can be, is one of the key preconditions you have to put in place. And it's a very long-term thing. You don't just do it overnight. You have to be seen to be doing it repeatedly.
The principle that's behind the shack process for nuclear
Exactly. Yeah.
Exactly that same thing.
Yeah, yeah. So they learnt, I think. They haven't got there, but they've learnt.
Okay. Question over there.
Hi, Lashko from Merlin Energy. I was wondering if you have any examples of where public perceptions have been really changed and it worked in that example to make public perceptions.
Yeah. It's an interesting question. You can certainly point to where. I'll give you two examples. One is obviously you can see. It's easy to see the examples when they suddenly change like that, or suddenly an issue arises. So the Kalara example was wonderful. Wonderful, not for DEFRA, but you could see straight away that people went from, well, trees are fine and they're safe, and then suddenly there's this big disease. That's well documented. And there are a number of other examples in the literature. Public, as you're changing the other way, nuclear power in the UK, we've documented from about 2000 to 2010, up till Fukushima, and then it remains resilient to Fukushima. UK attitudes to nuclear power steadily softened, let's put it that way, and certainly compared to Germany, many other countries, a more positive, if slightly ambivalent view, and to the point where there were more people pro-nuclear than anti-nuclear in the UK. And why did that happen? Quite complicated, but a narrative had been established by government, by the industry. I'm not saying there was any kind of conspiracy to do it. It just happened. Some very prominent NGOs as well said climate change is a serious problem. Nuclear power is part of maybe part of the solution to this. Therefore, we may need to rethink some of our views on nuclear energy. And so the discourse was reframed. And actually, some of the key environmentalists also stating that, I think we're pretty critical to that change. And it happened in a very gradual way over a very long period of time. But it did mean that when the government eventually came around to make that decision, rightly or wrongly, to go ahead with nuclear, which the programme seems in a bit of a mess now, the public didn't come out and say, no, we don't want this entirely. They don't want a huge expansion either, if you look at the data, just sort of renewal at the existing sites. That's sort of what seems to be in public views currently. But yes, it did change, but it was a very long process that occurred.
Okay, I think we'll have to stop because we need to keep to time. So I think Nick is going to be here all day, so if you're interested in talking to him, he's certainly available at tea breaks and at lunchtime. Thank you very much.
Yeah, absolutely.